Hello everyone, this is Professor Kuehn, and welcome to Introduction to Astronomy. In this course at Wisconsin Lutheran College, we'll be studying the works of ancient, medieval, Renaissance, and modern astronomers and scientists. But before we begin looking at some of these texts in detail, I think it's a good idea to familiarize yourself with the motion of the night sky. I know some of us have done some stargazing when we were young or in recent years, but some of us probably are not that familiar with stargazing. That's okay, this is an introductory course. But I think in order to understand the scientists who are talking about astronomy, it's going to be very helpful to get a bit of familiarity with the motion of the sky before we start into their texts. Now, we're going to be spending quite a bit of time this semester going outside and stargazing, looking at stars, planets, the motion of the moon and the sun. But there are very nice resources online and with your computer that will allow you to familiarize yourself with the night sky at the comfort of your desk. There are many of these kinds of programs. I like Luminos and others, but there's one that I particularly like. It's called Stellarium. This is freely available to download onto your PC or your Mac or even your mobile device. So I'd highly recommend that you download Stellarium and install it. What I want to do in this lecture is begin familiarizing you with some of the features of Stellarium. So I've already downloaded this software, and I'm going to click on it, the icon for Stellarium right here. And when I do so, Stellarium opens up, and I want to spend a little bit of time familiarizing you with some of the settings and how to operate this program. You see right now we are looking in a basically southerly, a little bit southeasterly direction across a plain, and you can see the sun up in the sky. I have the settings so that we're viewing from the location of Wauwatosa, Wisconsin, where I'm located. At the very bottom of the screen, you can see the time. It is 10:32 in the morning on August 24th of 2020. So before we start moving around in the sky and identifying objects, let me show you some of the settings. If you move your cursor off to the left side of the screen, there are some tabs that should pop up. So if you move off to the left side of the screen, you'll see these tabs pop up. And let me just tell you what these tabs are. The first one is the location window. That is used to set the location from which you are doing your viewing. Like I said, we are currently viewing from Wauwatosa, Wisconsin. We can set that to be a different location. You can view from Algeria or Abu Dhabi or Minnesota or wherever you want. The next one is the date and time window. If I were to click on this, I would be able to set the time at which I am doing my viewing. So I could be viewing right now, or I could be viewing 10 days from now, or 1,000 years in the past. And insofar as the computer program is accurately modeling the motion of the sun, the moon, the planets, and the stars, it will give me a correct view of what the sky looks like at the time that you set the date and time window to. We'll come back to this more later. There's also a sky and viewing options window that's going to let you see the various markings in the sky. It'll label the planets. Right now you can see the sun is labeled. We can label additional objects. The next one is the search window. It allows you to search for different near and deep sky objects. And then there's a configuration window that's used to do some additional setup. In addition, on the bottom, there are a number of different tabs right here that allow you, these are kind of shortcuts to turn on and off different features. And we'll come back to this more later. So let's go ahead and click on the location window. And when we do that, you can see a map of the world pops up. And there's a red arrow indicating the position from which we are doing our viewing right now. We are in Wauwatosa, Wisconsin, just west of Milwaukee. You can see that there's information about our current location. We are at 43 degrees, 2 minutes and 58 seconds, 0.06 seconds, north latitude. For those of you who aren't familiar with this, notice that that's given in degrees north of the equator, 43 degrees north. But it's also broken into fractions. So every degree is broken into 60 minutes. So we are 2 minutes north of 43 degrees north latitude. Furthermore, each minute is broken into 60 seconds. So we are 2 minutes and 58 seconds north of 43 degrees north latitude. We'll come back to that more later. Notice also our longitude is 88 degrees, 0 minutes and 27.33 seconds west. That is west of the prime meridian that runs through England. Notice our altitude is 201 meters above sea level. If we were to want to, we could set our location to a different place. Oops, I must have accidentally set some tab. I won't worry about that right now. But let's suppose our setting, we want to view from, Flagstaff, Arizona. Maybe there's some setting that went wrong here. Let's try this again. We can just click here to different locations. So let's go to Afghanistan. Okay, so we're in Ibok, Afghanistan. That is what the sky would look like right now in Ibok, Afghanistan. If we wanted to go to, Rio de Janeiro. That's not picking it up. Let's go someplace. Let's just pick a city here. So let's go to Guntakal, India, right there. That's what the sky would look like in India right now. If we went to Santa Barbara, California, Santa Barbara, United States, that's what the sky looks like in Santa Barbara. Okay, so let's just go back to our current location, go back to Wauwatosa, Wisconsin, click on that, and now we're back in Wauwatosa. Later on, we're going to go to different locations and see how the sky looks differently, but I just wanted to lay that out for you. Okay, let's go to the next tab, the date and time window. When we click on this, a calendar opens up that shows us we are on August 24th, 2020 at 10:36 in the morning and 49:50 seconds. Okay, if we want to, we can move forward in time by the minute or by the hour. We can go back in time. So if we went to 10 o'clock, 11 o'clock, 12 o'clock, notice the sun went off the top of the screen, 1 o'clock, 2 o'clock, and we can go back in time like this. Okay, let's go back to right now. Down here, set it to right now. All right, and notice we can go ahead in years or months or days. Okay, if we want to look at how the sun moves through the sky gradually, we can use these tabs down here. Right now we've hit play, which makes it go forward. We can set this to now. We can also make it go more quickly by going fast forward, and then we can watch the sun move slowly across the sky like this. 10:44 in the morning. Let's open up our date and time window. 10:51, 2, 3, 4, 5, so on. Okay, so you can see the sun moving. Let's go back to just regular speed and set it to now. Okay, so that's our date and time window. I'll close that. Next, we can go to Sky and Viewing Options window. This is a very important tab because it allows you to mark different things. So right now we are going to be able to view stars. We can't see any stars right now because it is daytime. And when there's daytime, the sunlight tends to swamp the stars. It makes it difficult to see them. If we wanted to see the stars during the daytime, there's this really nice tab down here called Atmosphere. And if we click on this, we can turn off the atmosphere. We can't actually do that in real life, but if we were to get rid of all of the air, what would happen? Well, click on that, and the sun still stays in the same position, but notice now we can see a lot more in the sky. The reason why the sky looks blue is because the sunlight is scattering off of the different particles in the air, reflecting preferentially the blue light and making the sky look blue. If we were to get rid of all that air, that scattering would go away, and the sky would look like this right now outside at 10:40 in the morning in Wauwatosa. We're going to turn on and off the atmosphere now and then to get a better sense of what the sky looks like during the day, but I'll leave it on for right now to make it more realistically appear to be what it is now. Okay, there's also various settings over here. I won't go through these all. You can play with these on your own time. There's also deep sky objects like galaxies, and we have it set up to show objects in the Messier catalog. We can look at the general catalog right here. I'm going to turn that off. We might come back to this later on. Markings. This is a very helpful tab here because it allows you to show a grid system in the sky. So I'm going to turn on the equatorial grid for right now. And what that does is it shows lines in the sky that are going to allow us to find the coordinates of stars, planets, and the sun. So let me say something else about this right now, just to give you a sense of what's going on. Remember how the Earth, every city on the Earth, can be identified by the latitude and longitude lines at which that city is located. The latitude and longitude lines are a spherical grid that is fixed, so to speak, to the surface of the Earth. Now, the sky, if we think about the sky as being a huge sphere around us, we're standing on the Earth looking out at the sky. Imagine the sky is an enormous sphere. One can place latitude and longitude lines on that sphere and identify the locations of the various stars, planets, and the sun on that grid system. Technically, they're not called latitude and longitude lines when you have that sphere on the celestial, when you have the markings on the celestial sphere or the sky, they're called right ascension and declination. We'll come back to that more later, but for now, you can just think about them as latitude and longitude lines. So right now, you can see the sun is located at just about 10 degrees north latitude, so to speak, above the celestial equator, which is right here, 0 degrees. And these longitude lines right here, they're actually called right ascension, and they're marked with hours instead of degrees. In any case, that's going to be an important grid system that we're going to be using. I'm going to leave that on for right now. There's also another important line that I'm going to put on here, and if I drag the sky a little bit, notice we're looking directly to the south right now. And if I turn on the meridian, you'll see that there is a green line that is basically going from directly south by the compass up like this. And it will go through the point directly over our head, the zenith. That is our local meridian line. And when the sun, as the sun moves through the sky, as it passes that meridian line, that will be local noon. So I'm going to leave that on for right now. I'll come back to that more in a moment. We can also change the landscape. The people who developed this program were French astronomers, and they set the landscape to look like Kuehn, which is a small French village in the valley of the Saône River, 50 kilometers north of Lyon, apparently. I'm reading this text right in here. Of course, we are in Wauwatosa, Wisconsin, but they've made the landscape look like it is in France. We could change this if we wanted to. It doesn't really change the sky at all, except it sometimes makes the sky a little bit harder to see. So for example, if we wanted to set the terrain to look like Hurricane Ridge in Olympic National Park. That's kind of neat. You can see the snow-capped mountains. However, the trees are a little bit tall. They're going to block some of the stars and make it difficult to see. So we will get rid of that. I kind of like setting it to be ocean so that it looks like you're standing on the ocean. That obscures the stars least. If you really don't want to see any stars, you can turn on trees, and that's like stargazing when you're camping in the forest. Okay, so let's go back to Kuehn, France, and do that. There's one other tab here called Star Lore. This is also a very nice tab that we can turn on and off constellation art. Okay, so if we're on Western art, and let me actually go to this shortcut tab and turn it on like this. So it overlays some artwork showing where the various constellations are in the sky. And it's using the Western traditional drawings. If we don't like these, if we want to try a different kind of tradition, we could, for instance, go to the Arabic tradition, and that will overlay Arabic constellation art from Arabic texts. We could pick Aztec, Egyptian, Indian, Vedic, Navajo, and so on. I think we'll just stick with the Western art for now because that's probably something that you are all most familiar with. Okay, so let's get rid of this option right there. Oh, actually, let's go back to it for a moment. And if we turn off, by the way, the atmosphere, you can see right away that these constellations are going to be overlaying various star patterns, various constellations. Okay, let's turn the atmosphere back on. All right, let's do a couple more things before we take a break. So what I want to do is I want to go forward in time and show you how the sun moves across the sky on a particular day. So let's go forward in time. We'll kind of zoom. Let's open up the time and date window. It's about 10:44 in the morning. Let's go forward in time a little bit more quickly. Okay, so it's 10:48, 49, 50. You can see the sun moving across the sky. I'm going to look up a little bit higher so the ground has dropped off the bottom, so it's harder to see the ground. But that way we can watch the sun. Notice that the sun right now is in the constellation Leo, the lion. The sun is approaching the local meridian. Right now it's about 11:30 in the morning. Notice also that all of these constellations are fixed on this celestial grid that seems to be rotating around us or moving past us. You see Virgo beginning to come into the screen on the left-hand side. Let me turn on the constellation labels. Okay. All right, so it's 12:20. The sun is approaching our local meridian. Right now we're in the morning hours ante-meridian, or before the sun passes the meridian. And here on August 24th, 2020, right around 12:54, that is when the sun is passing our local meridian. That is the local noon here in Wauwatosa, Wisconsin. Notice it's not at noon according to the clock. It's after noon according to the clock, and that has to do with where we are sitting in the time zone. Right now it's about 1:20 in the afternoon according to Stellarium, and so the sun is after the meridian or post-meridian. Okay, let's go a little bit faster, and we can watch the sunset. Okay, so now we're turning the sky to look a little bit more like it's going to the west, and the sun is going down. Right now it's 4:30, 5:30. I'm going to stop it right after sunset. And the sun is setting right around 7:30 or so. Okay, so the sun has just set. It's in Leo. Let's look back to the south right now. So we're turning the sky so it looks back to the south. I'm going to let this go forward in time a little bit faster. Okay, and you're going to notice as the sky gets darker after the sunset. Right now it's about 7:40. And you can see here Jupiter and Saturn beginning to appear in the southern part of the sky. It's a wonderful time right now to go outside just after sunset and see Jupiter and Saturn. If you look toward the south, the brightest thing in the sky, apart from the moon, of course, which is in Libra right now, it's about a half moon, the brightest thing in the sky will be Jupiter and Saturn. Jupiter is a bit to the west of Saturn right now. Okay? And if we look toward the east, just after sunset, let's go forward a little bit faster in time. We're going to see Mars rise. It's in Pisces right now. There we see it. Mars just rose around 10:30 or so. And I'll go back to regular speed. And there we have it. We have Mars. So if you go out at 11:30, about midnight, you'll be able to see Mars in the eastern part of the sky. It's in the constellation Pisces. Okay, so tell you what, I think that's enough for you for right now. I'm going to stop here, and during the next lecture, I want to talk a bit more about how the sun moves through the sky during different seasons of the year.